All right, so in this lesson, we're going to look at dividing radical expressions. Now, remember in the previous lesson, the one right before this one, we looked at multiplying radical expressions. So this one's, we're going to divide radical expressions. Now, in the previous lesson, we talked about the product rule or property of radicals. And so remember, the product rule for radicals said this: if you're multiplying one or more radicals together and the indices are the same, then you can write it as one radical by just multiplying the radicands together. Okay, so notice the radicand is a times b. All right, so the for the division, this is going to be called the quotient rule. So the quotient property or rule, property or rule for radicals. So instead of multiplying, we're now dividing. So hence the idea that the word quotient. So the quotient rule for radicals says this: if you have the nth root of a divided by the nth root of b. Okay, so the nth root of a divided by the nth root of b. Now we're assuming that b is not zero. All right, so we're going to assume that b is not zero. Because remember, you cannot divide by zero, so that makes them undefined. So as long as b is not zero, then the nth root of a divided by the nth root of b is if the indices are the same, then you can write this as one radical, and is the numerator, the radicand of the numerator divided by the radicand of the denominator. So it'll be the nth root of a divided by b. Okay, so that's the quotient rule. So let's look at an example. So let's go ahead and simplify. It may say the word simplify, or it may say divide. Just keep that in mind. So number one, you have the square root of 27 divided by the square root of 3. So the square root of 27 divided by the square root of 3. So notice that in both cases, then the numerator and the denominator, the radicals, the indices are the same. They're both 2's, hence that idea of square root. So according to the quotient rule, I can write this as 1 square root by just writing it as the square root of 27 divided by 3. And now 27 divided by 3 is 9, so this becomes the square root of 9, and 9 is a perfect square, so the square root of 9, remember the square root of 9 means what times itself is 9, so the answer is 3. So in this lesson, in the previous one, remember when we got to this point, the radicand was a perfect square or a perfect cube. Um, if it was not, it would be in the next lesson. So we're going to look at what happens if those are not perfect squares or perfect cubes, and that's going to be the next lesson or a future lesson. Number 2. So it's not that difficult, fairly easy to deal with. The square root of 160 divided by the square root of 10. Well, again, the indices are the same. I'm dividing, so according to the quotient rule, as long as the indices are the same, then I can write this as one radical. So I can write this as the square root of 160 divided by 10, and 160 divided by 10 is 16, and that becomes the square root of 16, and so the square root of 16 means what times itself twice is 16, so the answer is 4. Number 3, we have the cube root of 16 divided by the cube root of 2. So notice this time again the indices are the same, and so I get the cube root of 16 divided by 2. I can write this as one radical now. Don't forget the cube root though. Make sure you put a 3. If there's no number there, so it's to be a 2, and it's no longer mathematically correct. So it becomes the cube root of 8. And remember, the cube root of 8 means what times itself? 3 times is 8. And so the answer is 2. So the answer is 2. Number 4, you have the cube root of 81 divided by the cube root of 3. So the cube root of 81 divided by the cube root of 3. So again, the indices are the same. So I can write this as 1 cube root, 81 divided by 3. And 81 divided by 3 is 27. And so I have the cube root of 27. And notice the cube root of 27 means what times itself 3 times is 27. So 3 times 3 times 3 is 27. So the answer is 3. Number 4, you have the square root of x to the 33rd divided by the square root of x to the 5th. All right, now before we go on, let's remind ourselves about something. And so remember in a previous course, when you divided like bases, so if I had x to the 8th divided by x to the 3rd. So when divided like bases, you subtracted exponents. So remember in the previous lesson on multiplication, we discussed that when you multiply like bases, you add exponents. So that's why we said 7 plus 31 is 38. When you divide like bases, remember you subtract exponents. So that'll be x to the 8 minus 3, which is x to the 5th power. So I just wanted to remind you about this because you're going to use this now. Okay, so let's look at number 4 now. So according to the quotient rule, for radicals, as long as the indices are the same, I can write as one radical. So I can write this as the square root of x to the 33rd divided by x to the 5th. And now remember, you can simplify this because when you divide like bases, you subtract exponents. So this becomes the square root of x to the 33 minus 35 is 28. Okay? And then remember we did in the previous course, so in the previous lesson rather. So what times itself twice, remember this means what times itself twice is x to the 28th. And so we saw a quicker way of determining what goes here, that's 28. We saw a quicker way of what goes here by just taking the exponent, dividing it by the index 2. So 20 divided by 2 is 14. And it kind of makes sense because x to the 14th times x to the 14, when you multiply like bases, you add exponents, you get 28. So the answer is x to the 14th. And again, assume that all the variables represent positive real numbers. So don't worry about absolute value at all. Number 5. So number 5, let's suppose we had this. Oops. All right, number 5. Okay, so number 5, we have x to the, all right, listed number 4 twice here. So that'll be number 4, this is number 5. Okay, this will be number 6. So number 6, let's suppose we had the square root of x to the 25th divided by the square root of x to the 7th. All right, so again, I'm dividing radicals where the indices are the same, square roots in both cases. So I can write this according to the quotient rule. I can write this as 1 square root. So x to the 25th divided by x to the 7th. And then I can use the exponent rules. So when I divide like bases, I subtract exponents. So that becomes, just remember what this is. Let me write it here. X to the 25th divided by x to the 7th means x to the 25th minus 7. So when you divide like bases, you subtract exponents. And then 25 minus 7 is 18. So I got x to the 18th. So this becomes the square root of x to the 18th. And remember what that means. That means what times itself twice is x to the 18th. So a quicker way to determine what goes here is to take your exponent and divide it by the index. So 18 divided by 2 is 9. So x to the 9th times x to the 9th is x to the 18th. So the answer is x to the 9th. All right, and let's do one more, number 7. Number 7, let's suppose we had the cube root of x to the 26th divided by the cube root of x to the 8th. Okay, so the cube root of x to the 26th divided by the cube root of x to the 8th. So that becomes, remember the indices are the same, so I can write, according to the quotient rule, I can write this as the cube root of x to the 26 divided by x to the 8. And remember, I can simplify this because I know that x to the 26 divided by x to the 8th, when I divide like bases, I subtract exponents. So it'll be x to the 26 minus 8. And then 26 minus 8 is x to the 18, right? All right, so I get x to the 18. And so this becomes the cube root of x to the 18. And then, so remember what that means. That means what times itself 3 times is x to the 18. And so it's easy to remember, it's easy to determine what goes here by just taking the index, the exponent, divide by the index. 18 divided by 3 is 6. So you need 3 factors of x to the 6. That's what that means. Okay, and so you get x to the 6 as the answer. All right, so that was dividing radical expressions.